Welcome back, everybody. So for this piece of our video lessons, we are going to look at a few examples. So you'll notice that I've got everything kind of mapped out here. We have two examples prepared. Example 1, we're going to start with the absolute value function. So we actually haven't done a lot of work with graphing that. So notice, just like with other functions, the input-output pairs make up the graph. So if the input is 2, the output is also 2. If the input is 6, the output is also 6, because the absolute value of a positive number is just itself. Same thing for 0. The input is 0, the output is also 0. But if the inputs are negative, like here with -4, the output is +4, right? Because the absolute value of a negative number is its own opposite. So there is that V shape. So we're kind of used to that being the shape of our graph. And now kind of going down here, we are going to look at this function here. G of x is equal to 1 minus the absolute value of x plus 3. So I'm going to zoom in because, as you know, I like to sort of write zoomed in. And I want to point out here, and some of you will find this helpful, that writing 1 minus the absolute value of x plus 3 is the same as writing the negative absolute value of x plus 3 plus 1. And some of you will find this helpful because some of you will see that writing it this way actually makes you tell what the transformations are more clearly. What I'm kind of guessing is that a lot of you will need to write it that way a time or 2 or 3, and then you'll sort of internalize the patterns and you won't need to write it that way again. But what I'm going to do here is I'm going to underline all of the changes that we have from the black to the blue, and those are our transformations. So you see x got replaced with x plus 3. We have this minus on the outside, and then we have this plus 1. Okay, so in order, let's describe them. So we'll do that here. So we have replacing x with x plus 3 is a shift to the left. So that was from one of our first transformations lessons. So we have a shift left 3 units. The minus on the outside, so that goes back to our reflections lesson, which was the one that we just had. So that's a reflection in the x-axis. Notice that it's not enough to just say reflect or flip. You have to actually say what you're reflecting in. And then last but not least, that plus 1 on the outside is a shift up. So shift up 1 unit. Before we go to graph, I want to point something out. So both of these, the reflection in the x-axis and the shift up 1 unit, these are both y-coordinate transformations or output transformations. And when we have this, we haven't seen this yet, and when we have it, that we have more than one transformation that impacts the same coordinate, we generally, as a kind of convention, do the reflection first. You don't actually have to do that, but it's a convention that's adopted, and we can talk more, and we actually will talk more about why we do that in the next example, but generally we do the reflection first. Okay, so now let's zoom back out. Okay, so keeping in mind these 3 transformations, so we have a shift left, a reflection on the x-axis, and a shift up, I'm going to pick a few points. So let's start with 2, 2. And I'm mostly picking these points at random. So we'll do 2, 2, we'll do -3, 3, and then we'll also do the origin. The reason I'm picking these 3 points, really there isn't much of one, but I want 3 points that define the shape of the graph, right? So I'm looking for that V shape, and these 3 points largely help us see it. Okay, so here goes. I'm going to do one transformation at a time. So first, I shift left 3 units. So 2, 2 goes left. Notice that only impacts the x-coordinate. Then I reflect in the x-axis. So I go down to the x-axis and then as many units further. And then I shift up 1 unit. So that lands me there. I'm going to write that point in blue. So this black point 2, 2 ended up at the point -1, -1. Okay, so that's where 2, 2 ended up. Let's look at where -3, 3 ends up. So first, we're going to shift left 3 units. 1, 2, 3. Again, that only impacts the x-coordinate. Now we reflect on the x-axis. So down to the x-axis, and then 3 more down. So we've got the same number of units down, above and below the x-axis. And then we're going to shift up a unit. So that lands us here. So the point -3, 3 ends up at the point -6, -2. Okay, and lastly, let's do the origin to get the point of the V. Now, watch. When we shift left, we end up here. And notice that this point is on the x-axis. So actually reflecting it in the x-axis doesn't do anything. So we stay put for the reflection, and then from there we shift up a unit, and we end up at this point here. -3, 1. So that's sort of the point, the turnaround point of our V. So now I'm going to really carefully sketch the V in. So there it goes. Like that. This way. And then same thing this way. Again, if you wanted, you could put little arrows on the ends there to indicate that the V goes on forever. So that blue graph is the graph of the blue function. And now that we have the graph, let's go ahead and talk about coordinate analysis. So remember, coordinate analysis is where we take some random point. So I'm just going to take some random point here. Like maybe let's take this one. Okay. There. And let's call its coordinates x, y. And we're going to trace the transformations on it. So first we're going to go 3 units left. So that's 1, 2, 3. Notice at this moment we've only impacted the x-coordinate. So the x-coordinate is now x minus 3. The y-coordinate has stayed the same. If you want, you can even sort of kind of label the interim. So this is x minus 3, comma y. Then we're reflecting in the x-axis. All right, well, what does that mean? It means we're going all the way down to the x-axis and then that many more. Okay, so there. Like that. Okay, so we're not done yet because we still have the shift up a unit, but at this moment, we didn't change the x-coordinate. It's still x minus 3y. It's still x minus 3, but the y-coordinate got flipped upside down. So the y-coordinate here is -y. And then last but not least, we're going to shift up 1 unit. So there is the final destination. That is where we end up. So notice that this last piece did not impact our x-coordinate. That's still x minus 3, but we added 1 to our y-coordinate. So it's -y plus 1, which we can also write as 1 minus y. So for part B of this first example, what is the coordinate analysis? So if we start with a point x, y on the graph of f of x, that ends up at x minus 3, comma, 1 minus y on the graph of the new function. All right, so let's look at the domain and range of the two functions. So in this case, the domain is all real numbers. So you'll notice the domain is not terribly interesting. The domain is all real numbers. And the range of the original function starts at 0 and then goes to infinity. For the domain and the range of the transformed function, again, since we started with an all real number domain, the domain of the transformed function is going to be all real numbers too. But in the next example, you'll see how that changes. And for the range, well, look, so the range, if you look at the graph, no y coordinate goes above 1. So the range is from negative infinity to 1. And I want you to notice that the reflection in the x-axis is what flipped it from being from 0 up to being from negative infinity to 0. And then the shift up is what moved it up 1 unit. So more and more as you play with these, you're going to see that the domain and the range reflect the transformations. You see the transformations in the domain and the range, provided that they're not all real numbers. Okay, so we're going to do the same sort of thing, but we're going to look at the second example. So our second example, we're looking at the square root function. We've worked with that before. So that is our base function. That's the function that we're transforming. And then the transformed function is the square root of 3 minus x. And I'm going to zoom in here so that we can look at it really clearly. The square root of 3 minus x. So you can write this as the square root of negative x plus 3 if you want. Or, and some of you may find this last one especially helpful, negative quantity x minus 3. So you'll see why this last one might be a really helpful way to think about it in just a second. In fact, I'm going to use the last one to talk through the transformations. So look, you have this minus on the outside here, and then you have this replacing of x with x minus 3. So those are the two changes. Whereas before you just had x underneath the square root, now there's a minus underneath the square root, and where before you just had x, you now have x minus 3. So the minus on the inside, if you remember back to our reflections example, our reflections lesson, the minus on the inside means that we have a reflection in the y-axis. And now look. So this is where I think it's really handy to write this last way, where it's negative quantity x minus 3. The x minus 3 is a shift to the right. 3 units. The reason that I'm going to encourage you to rewrite the square root of 3 minus x, or a function like this, in this format where the negative is factored out, is that you can see really clearly that if in fact you do the reflection first, which is our general rule of thumb, you don't have to do the reflection first, but that's generally our convention. We reflect first. Once you've done the reflection, the shift is to the right, not to the left. Whereas here, you don't see that as clearly. You don't see clearly. You have the plus 3, and that feels like a shift left. And the reason that there's that confusion is that it's all about which you do first. Are you reflecting first, or are you shifting first? So if you reflect first, which is kind of going to be our convention, after you reflect, it's a shift to the right. If you have more questions about it, feel free to ask me in the a discussion, but generally speaking, we're going to do the reflection first, and that's going to be how we think about this. Okay, so let's go up here and let's actually do this graph. So I'm going to do the same thing that I've always done. So I'm going to start with a few points. So the points that I'm going to look at are going to be, let's look at 0, 0. Let's look at 1, 1. And then let's look at 4, 2. Okay, so I'm going to do 0, 0 last because, again, there's going to be that little confusion about the reflection. So let's start at 4, 2. So 4, 2, we're going to start by reflecting in the y-axis. So we're going to dot over to the y-axis and then keep going all the way over here. You can see it's right on the very edge of our picture. So this right now is the point negative 4, 2. And now we're going to shift right. So we're going to go back 3 units. And we're going to end up there. So the point 4, 2 ends up at the point negative 1, 2. Now the point 1, 1. So here we go. Reflect in the y-axis. So that ends up here. And then from there, shift right 3 units. 1, 2, 3. So there is the new point. That is at the point 2, 1. Notice that neither of my transformations impact the y-coordinate. And then 0, 0. So the reason I left 0, 0 for last is that when you reflect that in the y-axis, nothing happens. It just stays put. So the only transformation you actually end up seeing is the shift right. So there it is. So this point is the point 3, 0. And what I'm hoping that you're seeing right now is that these blue points flesh out the exact same shape as the black points we started with, but kind of flipped over. So here is the graph. I'm going to draw it in. Again, do your very best to make a nice graph. But a graph is not meant to be perfect. A graph is meant to communicate a general idea. So there is our graph. Okay, now that we have the whole graph, let's look at the graph to determine coordinate analysis. So I'm going to pick some random point. So let's pick this one here. Okay, so we'll call this point x, y. I'm not particularly paying attention. Actually, let's not pick that one because it's off of the grid as far as our picture is concerned. So watch, we'll pick this one here. Okay, so if we pick this point and its coordinates are x, y, when we reflect in the y-axis, we end up here. So this point, it's not our final location, but same y-coordinate, opposite x-coordinate. So negative xy. And then from there, we're going to shift right 3 units. So we're going to go, and there is going to be our final point. So all we did in that last step is we added 3 to our x coordinate. So it's going to be negative x plus 3, which we can write as 3 minus x, comma, y. So we can say that our coordinate analysis, if we start with the point x, y on the graph of f of x, we end up with the point 3 minus x, comma, y on the graph of g. So that is our coordinate analysis. What many of you will notice is that at first, you will need to first do the graph and then do the coordinate analysis, but as you get more comfortable with what the different transformations do, you'll actually be able to do the coordinate analysis first and then use it to sketch your graph. So eventually the coordinate analysis is going to start being a tool rather than a supplementary step. Okay, let's talk about domain and range. So here domain and range are pretty interesting. So the domain and the range of f, so the domain is not all real numbers. It's all the numbers from 0 to infinity, and the same is true for the range from 0 to infinity. Now, talking about the domain and the range of g, remember none of our transformations impacted the y-coordinate. So the range is the same as it was. It's still from 0 to infinity. But the domain, so remember we have a reflection in the y-axis which causes it to flip over. So that would cause it to go from 0 to infinity to negative infinity to 0. But then we also have a shift right. So instead of stopping at 0, it goes all the way to 3. So the domain and the range of G are, the domain is from negative infinity to 3, and the range is from 0 to infinity. So here we have two examples that combine translations and reflections. Stay tuned for our final lesson and our final example video on transformations. Bye.